Okay, the first thing that I like to do is, before I put my telescope on the tripod in the wedge, I like to level the tripod. So I take a level and I put it along the axis of each leg of the tripod. So that leg's good. That's looking good. I did this earlier. And that's looking good. Okay, next thing I do is I put my wedge at the latitude of my location, which is about 42 here in New England. So 42 is about right there. Lock it down. Alright, place that on the wedge. And there it is. These fork mounts are heavy. Eventually I'll upgrade to an equatorial mount. For now, this will have to work. For those of you wondering how to use a wedge, you install this knob first onto the base of the telescope. And you could see that the wedge has a built-in slot at the top that allows you to slide the telescope on the wedge without it falling off. You sort of have to tighten that one up, and then you have two more holes down here. I will be auto-guiding tonight, as I normally do, to track whatever object that I'm imaging. For auto-guiding, I will be using a Astrotech ED72 doublet apochromatic refractor, which I originally bought to image with. I just have more of an interest in higher focal lengths and getting really close to objects, especially galaxies. I understand a lot of you astro-imagers out there enjoy wide field views, but that's just not the case with me. So here's the finder scope bracket, which originally was on this OTA, and you can see all I do here is slide it in, and I found this sort of on a whim. I was messing with it, and one day I found out, oh, the dovetail fits, so this is how I've been doing it. Just tighten those screws up nice and tight, because you don't want any flexure. And there we go. Now, only if my Schmidt had a dew shield like that. Okay, next, finder scope. Really useful for just finding the area where your object is, or really useful for polar alignment, finding those stars. So slide that guy in right there, tighten that up. Before I get the telescope balanced, I like to put on everything that I would normally have on during my imaging session. So this includes an extension tube, which is from a 2X Barlow I used to have. Alright, so this is necessary to bring the Orion Starshoot autoguider into focus on my ED72. Without this extension tube, I cannot achieve focus with this refractor. So just tighten these knobs up, make sure everything is secure. You don't want your CCD camera falling into the mud. Alright, let's take off the focusing protector. And to make things a bit easier tonight, I will be using an f6.3 focal reducer made by Meade for Schmidt-Cassegrain telescopes. So that thread's on the back. Time to thread on the diagonal and to install the eyepiece. So at this point, putting this combination on is about the weight of my DSLR on the back of the telescope. So when I put this on, I do my balancing, and usually if I put the camera on after that, everything is fine and balanced. So I use this eyepiece to frame up my object, whether or not I can see it. So some deep sky objects are too dim to see, especially in this light pollution. But if you know what stars or patterns of stars are around the object, you're able to frame it. So I use a nice wide field 42 millimeter 2-inch Kellner eyepiece for this. So let's thread that on, get this balanced. Alright, there's that. Now undo your clutches, check for balance. Pretty well balanced, I would say. Yeah. Now the mount won't have to work so hard. Alright. Very nice. Alright, there's that. Now undo your clutches and check for balance. Pretty well balanced, I would say. Yeah. Now the mount won't have to work so hard. Just a quick overview of what we have on so far. Here's the f6.3 focal reducer attached to the diagonal and 42 millimeter eyepiece, which I will be using to frame up my objects. Now the focal reducer reduces this telescope from 2500 millimeters to 1575, if you were wondering. That's 2500 multiplied by 0.63. So there's the corrector plate and the dew heater and this dew shield thing, whatever you want to call it. There's my guide scope, the ED72. Got the Orion Starshoot auto guider on the back of that with the extension tube. Finder scope, 8x50. Wedge. And my counterweights with this sort of custom counterweight bracket that I got off my 8-inch. It was too short, so I had to extend it using some brackets and screws. Alright, it's looking good and it's getting closer and closer to a complete setup. But we're not there yet. Time for my favorite part of astrophotography. Just kidding, this sucks and I hate it. But it is necessary to get to imaging and get everything automated and working well. Otherwise I'd just be looking through that lens, really doing nothing. So I have a serial port connector to connect the mount to my laptop. I have auto guiding camera cables and DSLR cables to connect those to the laptop. I bought this USB extension, which hopefully will prevent my telescope from strangling itself at 3:30 a.m. I have an auto star controller necessary to operate the mount, and a declination motor wire, which is required to operate the declination axis on the telescope. And then an AC converter for my DSLR, so I don't have to come out here and change batteries and probably screw up focus and other things. And just an old laptop and laptop charger. Auto star controller. Connect that to the HBX port. Declination axis cable right there. Throw it around here since the telescope tends to rotate clockwise. I don't want that getting tangled up, so connect that. Alright, then we connect this to, let's just move that right there. Connect the serial port to the AutoStar controller. This is specific to Meade telescopes for the most part. You have to use the AutoStar controller. Other telescopes you'll have, or other mounts, you'll have this cable connect directly to the mount. Not the case with Meade. Alright, so that's connected. Then your auto guiding cable on. Right here. So I've already set up all these COM ports so that they recognize whatever I'm plugging into them. Okay, auto guiding cable set up. Got my serial port connected. Alright, that's like 30% of the cables done. I almost forgot to mention, you want to install a dew heater on your guide scope as well, because, well, for the same reason you install a dew heater on your main scope to prevent dew. So to control my dew heaters, I use my portable battery that I would use to control the scope if I were to take it somewhere. The reason for this is because this has these cigarette lighter ports, which most cars have, and the dew heater cable has that connection. So I just put that in the battery, and I actually end up plugging the battery in so that it doesn't run out during the night. So it's got a USB port in here, which is really nice, because then I can connect the dew heater on the guide scope, which has a USB connection, rather than a 12-volt car cigarette lighter connection. So one thing I find that's important for cable management is to keep the cables that move away from the cables that stand still. A cable that stands still, for example, would be the charging cable for the laptop, anything that powers the telescope from the outlet, the COM port connecting to the AutoStar controller. These things don't move. They're connected to either the base of the telescope or the power strip coming from the house. The cables that move would be the dew cables for the dew heaters, because those are connected to the telescope, along with the auto guiding cable and DSLR AC converter cable. You want to keep these separate from the cables that don't move. Otherwise you can have a disaster where one of the moving cables gets caught on something that doesn't move and drags something off of your imaging table or something like that, and you don't want that. Even the declination cable is something to keep your eye on. That has taken things off the table before. So we have an astronomic CLS filter. This is a broadband light pollution filter. CLS stands for City Light Suppression. So it blocks out any of the wavelengths associated with light pollution. This is necessary for imaging in this area and to get a decent signal to noise ratio in my images. So I'm finally finishing up cable management. So you have this extension cord running from the house over to a chair. This sort of elevates these components so that they're not too far from the telescope. Got a power strip. Laptop is plugged in. The only moving cable that's coming from the power strip is the AC adapter for the camera, so this needs to stay away from everything else because it'll be moving with the telescope as it tracks. I got my battery on the table, and this actually helps keep the table in place in case there's a little bit of wind. But if there's wind, and my images are ruined anyway, but at least the table won't flip over and my laptop won't end up on the ground. Alright, time to do a little test. See if everything's balanced and working. So now you can see the importance of keeping all of these moving cables away from cables that don't move.